we're going to prove a corollary to the last theorem. I will post a link in the description to that last video where you can watch the proof of the last theorem. This says that if you have an orthogonal set of vectors, then that set is linearly independent. Now, the previous theorem stated the following. It says, let S be an orthogonal set of non-zero vectors. Then S is linearly independent. So what is the difference between what we have here and the previous theorem? Well, I see two differences. Here we have an orthonormal set. I might have said orthogonal when I read it. I apologize. And down here we have an orthogonal set of non-zero vectors. And the proof for this theorem just really talked about two things. One, that none of the vectors were zero, and that the dot product of two different vectors in this set equals 0. Well, orthonormal means that any two vectors are orthogonal. It means it's an orthogonal set. This is an orthogonal set where the length of each vector is 0. So we have an orthogonal set in both. So you have non-zero vectors. Ooh, an orthogonal set doesn't have 0 vectors because the length of a 0 vector is 0, which is not 1. Okay. So what we have is this. The 0 vector is not in this orthonormal set, since the length of the 0 vector is 0, which is not 1. Okay, and also the orthonormal set is orthogonal. Those two are the only conditions for said S to be linearly independent. Since an orthonormal set has those two conditions, it follows immediately. It follows that an orthonormal set of vectors is linearly independent. Okay, so again, we just showed that the set in the theorem, the set of orthonormal vectors, it doesn't have the zero vector, and that the orthonormal set is orthogonal. Well, the previous theorem said if you have an orthogonal set and it doesn't contain the zero vector, it's linearly independent. That completes the proof. It was an immediate consequence of the last theorem. All I had to do was say that an orthonormal set doesn't contain the zero vector and it's orthogonal, and then from the previous theorem, this set must be linearly independent. If you like videos like this, please subscribe to my channel. Watch and learn. See you in the next video.